Hello everyone. In previous couple of lectures or 3-4 lectures, I talked about different counting principles, multiplication and permutation, multiplication principle and permutation. Here I'm going to talk about combination. As definition suggests, the possible collections made out of certain objects are known as combination, and order of the collection doesn't matter. So that is the basic difference between permutation and combination. In permutation, the order of collection matters, and in combination, the order of collection doesn't matter. If I look into the formula for combination, if I have to choose R objects out of total N objects, then I can write it NCR. So I have to choose R out of N. So definitely R is always going to be less than equal to N. And this can be given by N factorial divided by R factorial and N minus R factorial. If you want to look into the formula of permutation, I'm going to write it side by side. It was R arrangements out of total N objects. They have been given by N minus R factorial. So you can see there is not much difference. I have just multiplied denominator by R factorial to get the combination. Let's see some basic results. If R is equal to 0, then it would become NC0 is equal to N factorial divided by 0 factorial and N minus 0 factorial, and which ultimately is going to give me N factorial, since factorial 0 is always equal to 1, divided by N factorial, and gives me 1. While if I try to replicate the same result for permutation, then it would become NP0, and it is going to be N factorial divided by N minus 0 factorial, which again is going to be N factorial divided by N factorial, and ultimately going to result in 1. So if you see NC0 is equal to NP0, they give you 1. Let's see some more basic results. If I have, let's say, I'm going to put combination results, R is equal to N, let's say, what do I get? I get NCN is equal to N factorial divided by R factorial, which is actually N factorial. Let me correct it, because R is equal to N, and this entry becomes N minus N factorial. It can simply say that N factorial divided by N factorial and 0 factorial, which is equal to 1. And what do I get? Absolutely 1. Now I'm going to replicate the same result for permutation. It is going to be NPN this time. I've got N factorial divided by N minus N factorial, and I get N factorial by 0 factorial, which is equal to 1, and I get N factorial. So when R is equal to N, the results are different. When R is equal to 0, the results are same.